Hello wonderful person, this is Anton, and what you're looking at right here is officially now the smallest dwarf planet in the solar system. This is known as Hygiea. Let's talk about it and welcome to What the Math. So what exactly is Hygiea and why is it that most of you have never heard of it? It's actually an asteroid, or it was, until now. The asteroid belt where Hygiea is located is filled with various rocks and various large objects, and at least one of them is already listed as a dwarf planet. And it used to be the smallest dwarf planet in the solar system. I'm of course talking about Ceres. And Ceres, which you see right here, has been in the news quite a lot, mostly because we've sent a mission here and were able to analyze its surface quite thoroughly, discovering some really awesome things, like for example this very reflective spot that seems to be extremely bright and may potentially hold quite a lot of water in it. But this video is really not about Ceres, because it's officially no longer the smallest dwarf planet. It's now Hygiea. So Ceres, which is about to collide with planet Earth, is really kind of losing its status as the tiniest object known as a dwarf planet. But first, a quick reminder on what dwarf planets are. Remember how a few years ago, specifically almost a decade ago now, back in 2006, Pluto lost its status as a planet and became what's known as a dwarf planet? It upset some people, but at the same time allowed us to create a new category of objects known as dwarf planets. And these are essentially objects that are not really big enough to be planets, specifically not massive enough to be planets, but are massive enough to maintain a spherical shape. So by definition, to be a dwarf planet, these objects have to be in orbit around the sun, they also have to be not moons of another planet, and at the same time have to be able to maintain a spherical shape like Ceres right here. This is the reason why Ceres is a dwarf planet, but a somewhat similar in mass object Vesta is not. Vesta is considered to be the largest asteroid because, as you can see here, it doesn't have this spherical shape. Now, the idea of a spherical shape comes from usually the actual density of the object. In simple terms, it refers to the idea of having so much pressure coming from the outside that sort of counteracts the forces from the inside, where the object sort of assumes the spherical shape. In some cases, for objects that are more liquid, or even more so basically contain gas like our sun, they'll often assume the shape and be almost perfectly spherical, with the only exception being if, for example, a star is really active and produces a lot of outbursts. This might actually change its shape a little bit, while at the same time, if the star spins really fast, or if an object spins really fast, it will also assume a kind of a squeezed shape that you see right here. This is another dwarf planet known as Hygiea. Now, so in a sense, you don't really need to be a perfectly spherical object to be a dwarf planet or a planet in general, but there should still be enough mass for this object to eventually assume a spherical shape. And so, in a sense, this is why the object like Hygiea is a dwarf planet, but an object like Vesta that's not spherical and cannot become spherical because it's basically made out of rock, which prevents it from assuming a spherical shape, is not a dwarf planet. But what about Hygiea? So for the longest time, we always suspected Hygiea might be a dwarf planet because it appeared to be spherical, but we didn't have good observation of this object, and we didn't really know what its true shape is. As a matter of fact, because Hygiea is part of a family of about 7,000 different large asteroids, we always assumed that it was not going to be spherical. We thought it was more rocky. But this is essentially what it was missing. It was missing the observations of its shape. For it to become a dwarf planet, it just needed to be looked at. And this is exactly what ESO did very recently using its VLT, also known as Very Large Telescope, located in Chile, where they essentially used a very cool device known as Sphere, which allows us to look at various exoplanets by blocking the starlight from the stars they orbit, and then by directly seeing these exoplanets. This is what we refer to as direct imaging of exoplanets. But it doesn't have to be always used with exoplanets. You can look at much closer objects here in the solar system. For example, this device was previously used to take a look at Titan, which you see right here. This is the direct imaging of the Saturn's moon Titan. And now we were finally able to produce the direct image of Hygiea as well. And as you can see here, it is more or less spherical, even though it is less massive and also much smaller than Vesta next to it. In other words, despite being a much smaller object and despite potentially containing relatively similar materials to Vesta, it ended up being spherical and gaining the title of the smallest dwarf planet. Now, the interesting thing about this discovery is not that it's basically the smallest planet, but why it became spherical to begin with. And this is where things get kind of intriguing, because the scientists behind this discovery were able to create a very specific simulation explaining how exactly they believe it became so spherical. And just like so many other things in the asteroid belt, it of course involves a really cool collision. But not just any kind of a collision, a head-on, really fast moving collision between two objects. And here is that simulation that ESO made to demonstrate what exactly happened. And you can see from the simulation here that the object became spherical simply because it was a molten piece of rock that eventually coalesced into this very beautiful object resembling a ball. So in other words, the main reason why it was able to create this shape to begin with is simply because of this head-on collision that allowed it to form the spherical shape that we see now. And if it wasn't for this head-on collision, it would not really be able to create this shape and would most likely be more similar to Vesta or any other asteroid with a somewhat irregular shape that we're usually familiar with when it comes to asteroids. And this is actually the fourth largest rock in the asteroid belt. It's not even the third. In between Vesta and Hygiea, there's another asteroid known as Pallas. And even though Pallas might be spherical, we're currently not entirely sure if it qualifies as a dwarf planet, but even if it does, it will never be the smallest, simply because Hygiea now has that spot. Now, in regards to the size comparison of these various dwarf planets that you see here, we can take a look at them and you'll notice right away that Pluto, which is roughly around 2400 kilometers in diameter, has already sort of overshadowed some of the smaller dwarf planets. And Hygiea is the last one at the end here. It's pretty small in comparison, with the recently recalculated diameter of about 430 kilometers. And it's very likely that no other dwarf planet will be able to beat this, unless of course it had a very similar condition where it was created and also possesses a spherical shape. But here you can see that even compared to Sears, this object is much smaller. And just to give you another point of reference here, this is what our moon looks like. Our moon is dramatically larger than all of these objects. You can actually compare the size of Hygiea to one of these dark spots on the moon that are known as mare. And so even though it might not be a very exciting discovery or really a discovery at all, it's more of a reclassification, it is nevertheless interesting how the scientists were able to uncover the origin of this unusual object. And the reason why it's so interesting is because we never really expected to have these really powerful head-on collisions in our solar system, but it seems that it has happened, and it may have been the largest and the most powerful such collision in the last 4 billion years. In other words, the creation of Hygiea may have been one of the most powerful collision events in the entire solar system. And the reason it was so energetic is simply because these two objects were moving toward each other pretty fast, creating a tremendous amount of energy in the process. I know that this might not compare to a typical planetary collision in the amount of energy released. It was still pretty impressive and may have been visible from around the solar system because of the large explosion produced. So in that sense, this discovery allowed us to see the past of our solar system and to analyze something we didn't really know existed or has happened. And this also indicates to us that these unusual collisions may be a lot more frequent and a lot more common out there in the galaxy than we always believed. Anyway, on that note, once we discover a little bit more about the asteroid belt or Hygiea in general, I'll make sure to follow this up. But until then, that's really it. Thank you for watching, subscribe if you still haven't, share this with someone who loves learning about space and sciences, and maybe consider supporting this channel on Patreon because it does help me quite a lot. I'll see you tomorrow. Let's watch these dwarf planets collide and see what happens at the end. Space out, and as always, bye bye.